This is your parent log graph, and if I made this base here be like a 3, a 4, or a 5, or a 6, it would just get sharper turn. But it would always go through that spot. So let's talk about what that spot would be on the XY charts. Everybody make an XY chart like this. You'll have to have the asymptote, and yes, there's an asymptote on this graph. And then you'll have to have a couple other points. Like literally, if you just have 3 would for sure work. There's a few functions where I'd only even expect 2 points in the asymptote. All right, so let's talk about this point. Would you agree that at that point, it looks like x is some small number? Would you guess what x probably is? Probably 1, right? All right, so let's put x equals 1. And let's write our equation up above this again. Y equals log base 2 of x. I just said x was 1. Do you remember that dumb little saying? I just won the argument. So what do I get? Nothing. It equals 0. Look at that. It equals 1 comma 0. See? I put in a 1 and my log turned into 0. All right, now, I've always been teaching kids to use strategic numbers. Don't just stick in 0. And in fact, if you had put in 0 right here, you would have gotten, you're not allowed to have a 0 there, right? Because that number is called the argument and it's supposed to be positive. You remember that? But if you can ever make that part 0, you found the asymptote. So let's put it on our little list. If I use 0, that's the asymptote. Whatever makes the inside 0 is the asymptote. So there's an asymptote at x equals 0, so it's right there. Yes?
Well, if you always put in 0 to x, will it always be the asymptote?
Yes, as long as you heard what I said. What I said is if you can make the inside be 0. So for example, I'm changing the problem now. Log base 3 of x minus 4. When I stick 0 right here, does that give me the asymptote? No. When I make the inside be 0, that's when I found the asymptote. So do you get that 4 in this case makes it 0? So then if I was making an XY chart for this one, 4 would be a key number because it would give me the asymptote. Why does it give me the asymptote? Because it makes the inside be 0. Okay. All right, so now I just need like one more point. Well, you get to pick what you put here. Isn't log base 2 of 2 something that would be pretty easy to do? In case you forgot, that's easy. And the answer is 1. Because the bases are the same. The answer's already there, which is the power on that. And so the answer to log base 2 of 2 would be 1. Do you get then why 2 is a smart thing to put in for x? Because when you put in a 2 there, you get log base 2 of 2, which is 1. So then if I go over 2 and I go up 1, look at that. And I agree, let's do 4. Why'd you pick 4, Carter?
Because then you can like simplify it to 2 to the second power, right?
Yes, so if I put a 4 here, I chose a 4, so I put it on my list. Then I've got a 4 here, which could be simplified, just like you said, to 2 squared. And when the bases are the same, it's just the power, which is 2. 4 comma 2. And look, 1, 2, 3, 4 comma 2. It is all matching up with like spots that are on this parent graph. It worked. Yay. Okay, that's how you graph. I could just say we're done. Start your homework. Seriously. It's just that I know that when these get complicated, people get really stressed. So I think we should do a few more. But that's pretty much it. All right, so find a new spot. I will get back to the slides in a second. If I just said, let's do something very similar. Let's graph y equals log base 4 of x. Make an XY chart. Now remember that one of the key spots is the asymptote. Chase, do you remember how to make the asymptote? What would I pick for x?
0.
Yep. Because if you make the inside here be 0, and that's easy this time, you just put in 0. Then you found the asymptote. And where is x equals 0? That's the y-axis. So there is a dotted line right there for my asymptote. You need that asymptote. If you don't have the asymptote on the test, you're going to get it wrong. It's really, really common for kids to forget that. So I'm telling you to just put it right on your chart. Now that we started and we know what the asymptote is, it's also a clue that somewhere near that is our next point. But would 1 be an easy one to work with or not? Because if it's easy, we'll use it. And if it's not, we won't. Do you like the idea of a 1 in the argument? If we put in 1, you won the argument. So what's the answer? 0. 1 comma 0, it works. 1, 0 is a dot right there. And I know what this looks like. I'm going to draw it. It looks like that. I'm just not sure exactly what the points are. So, all right. Now let's pick another thing. But is 2 just going to automatically work nice? No, but we might actually be able to like really think it through and make it work. But why? Why do I want to go to all that work? Sure, I could somehow make that be in 4 to a power, but it's just too much work. I don't want to do it. So I don't pick 2. What would be easy? 4. Log base 4 of 4 would be easy, so use 4. And then it's 1. I got 2 points. Is that enough? I said 3. All right, I'm going to give you another one that is a really easy one to get for no matter what the base is. You want to make the base, but you want to make it 1 over the base. I'm going to stick in 1/4 right here because that's 4 to the -1. Think about that. If I stick 1/4 in, I now have something that I can replace with 4 to the -1, and then that means the answer is -1. Cool, that was easy. Again, if you don't get that, it's because log base 4 of 4 to the -1, maybe you're not good at these yet, but that's just 1/4. And if the bases are the same, the answer's already there. And so it's -1. That's a point, that's a point, that's a point, and that's the asymptote. So 1/4 comma -1 also gets us a point that's somewhere in there, which gets us closer to the asymptote. So there we go. I just kind of missed it, but that was pretty much the graph. All right, so I just want to do a few where I show you what numbers would you pick? Log base 4 of x minus 7. Hint, you wouldn't just start with 0 on this one. What are some numbers to pick? 7, because it makes the asymptote. And now I know on my graph that at 7, there's an asymptote running like this. And then, that also tells you you're really close to the next one. If you put in 7, try putting in like 6 or 8. And if you put in 6, it won't work because you can't have a negative in the argument spot. So 6 won't work, but 8 will. Because then I have a 1 in the argument, and when you get a 1 in the argument, you get 0. What else would be good to get it put in? We'll just try 9 and see what happens. And log base 4 of 2 is kind of a pain in the butt. It can be done. I just want to show you that it can be done. If I put a 9 there, I'm going to have log base 4 of 2. And the 2 could be written as 4, but square root. Do you agree that 2 is 4 square root of 4? See how I did that? See that the answer is a half then? So if I wanted to, I could put in 9, tweak the 2 to be 4 to the 1/2, so my answer is a half. That's not a bad way to go. I just need one more point. Hint, it's not 10. 11? 11 minus 7 is 4. Log base 4 of 4. Ooh, that's going to work pretty well. Log base 4 of 4 is 1. And then you just have to graph these 3 points. That's all there is to it. Okay, so let me just show you how gross they could get. Imagine a world where it's 3 in the front, then a log base 3, and then an x minus 7 on the inside. And then a plus 6. Holy crap, we'd have to do that? Maybe. Maybe it wouldn't be quite this bad. Let's make it a little easier, because I'm trying to make it like what we actually do on a test. I think we'd probably only do 2 things, like maybe the minus 7 in there and the plus 6 at the end. Okay, let's say this was our test. I know you can graph the points, just what are the points? Keenan, give me a smart thing to put in.
7.
Good, because it gives you the?
Asymptote.
Good. Something close to 7, Max Hawks, what do you think? 8. Put in an 8. I got, I won the argument. I get nothing, but the answer isn't 0. Because you add 6. Y equals, that's 0 plus 6, so it's 6.
Why would 7 be?
7 was the asymptote.
But don't you have to add 6?
Because this thing, as soon as you found the asymptote,
Oh, yeah, pretty much.
you don't have to do anything more. Like you can't have a 7 here, really. You know what I mean? It's like this part right here is all of a sudden like not doable because you have a 0 in the argument. So, all right. So we tried 8 because that was close to 7. How about just try 9? It won't work real nice though. 9 minus 7 is 2, so I don't want to do log base 3 of 2. It's a pain, so I'm not doing it. How about 10? That works. So I stick in 10. 10 minus 7 is 3. Log base 3 of 3 is 1 plus the 6. 7. And I'm getting close. Now let me just show you how I said it's really cool if you can make this part 1/3. So you might be like, how on earth am I going to make that 1/3? I can just say I want x minus 7 to come out to 1/3. And then math will solve it for you. Add 7 to both sides. And I get x equals 7 and 1/3. Apparently that'd be smart to put in. I'll try it. 7 and 1/3 goes in. It's just a little past 7 on the graph, okay? So when I put in 7 and 1/3 and I take away 7, I'll have 1/3. Why is that good? Because log base 3 of 1/3 works nice. Because that's really 3 to the negative 1. So it comes out to negative 1. Don't forget to add the 6. Negative 1 plus the 6 comes out to 5. And that would be 3 points. Could you have found another one? Sure. You can try putting in 11, 12, 13, 14. Let's see, 13 I think might work. No. I'd like it to be 9. So again, if I'd like it to be 9, I can go, I want x minus 7 to come out to 9. Add 7, add 7. Oh, go 16, or sorry. Yeah, 16 would be a good number. And when I put in 16, this part becomes 9, and that works nice. Log base 3 of 9 is 2. 2 plus the 6 is 8. I can keep doing this all day. question is, can you keep doing this all day? Can you find these points? All right, so one last one with the kid next to you to check you. I want you to figure out what's the smartest thing to put into this function for log base 2 of x minus 3. And I want you to figure out 3 smart things to put in. No, 4. One will give you the asymptote, and then 3 other points. Figure out 4 smart things to put in. Talk to them. Like, I think this is going to work right. Okay. Albright, I'm pretty sure you knew where the asymptote was. What do you put in? 3 gives you the asymptote. Good. Keenan, I bet you know a number to put in. 4 was good to put in. And Max Hawks, another number? 5. And yeah, that makes log base 2 of 2. That'll work nice. Don't forget the 4 in front, everybody. 4 times whatever your answer was. And Rebecca, give me a number that works besides 5. 1. 1 minus that makes a negative 2. You can't have a negative there. Okay, good try. You got one? 3.5. Ooh, 3.5 does work nice. Because then all of a sudden you'll just have a half in there, which is 2 to the negative 1. That'd be smart. And I hear 7 also works. Is that what I'm hearing? All right. See how there's a whole bunch of choices? All right. Ethan, what did you get when you put in 4?
0.
Yep. Let's go with Tate. What'd you get when you put in 5? 4 is correct. Who actually put in 3.5? Be brave. Be brave. What'd you get? Negative 4. I think he's right. Is that accurate? Anybody else get that?
Yeah.
Okay, good. And last but not least, 7. If I put in 7 here, 7 minus 3 is 4. Then log base 2 of 4 is 2. 2 times 4 is 8. Make sense? If you can find those points, it's easy. Graphing the asymptotes at 3. 4 comma 0 is right there. 5 comma 4 is like there. And then the graphs always generally look like that. Now, could we make a move? Yeah, you could make it even flip. Do you get if you put a negative here? That would make the whole graph flip. But you don't have to worry about that. As long as you include that negative in your answer, all of these would have come out negative. Negative 0 is the same, but negative, that would be positive. That'd be negative. Anyway, moral of the story is we could get all the points would take care of themselves. If you just put in the negative, and you graph those points, this whole thing would be like flipped like that. And it'll take care of itself. You don't have to flip them. If you just do the points right, it'll tell you where the graph is. All right, now the last part is a review of yesterday. There was a bunch of little patterns. If you know the answer to this, don't say it, raise your hand. How about this? I promise not to call on you, but if you think you know it, raise your hand. I'll use the dice to call on somebody. All right, not that many people know this. Please talk to the kid next to you about what you think that answer is.
Does it get rid of it?
Bases are the same. What's the answer? 4. If the bases are the same, the answer's already there. Could I write this as like x and then redo it? Because like this one is technically not a log. This one's technically an exponent on a base. So then I'm going to rewrite it as a log. And the base would be 5. And then you always go like this. And I could do all of this, but it seems like it'd be kind of a pain because I know the pattern. If it's bases are the same, the answer's gonna come out to that number, and look at this. It's still coming out to 4, because these would have to be the same. All right, here's another pattern. Log base negative 3 of 1, and I get some of you are gonna be like, oh, won the argument, I get nothing, and that's wrong in this case. Why is it wrong?
Just no solution.
You can't have a negative 3 base, what's the answer?
No solution.
No solution, undefined, good answers. Okay. All right, what if I put a negative 3 here and a negative 3 there? Then these numbers are the same, so the answer's 1, right?
No.
No, can't have negatives there, no solution. How about if I get rid of these? Then what's the answer? 1. How about now? What's the answer now? 4. What if I change this to 1/3? Negative 1. Because it's like this is 3 to the negative 1. Very good. Okay, then do you remember how to add them? Can I add log base 3 to log base 3 of something? Yeah. And if this is a 4 and this is an x, what would it be on the inside? 4x. Log base 3 of 4x. And then if I had a log base 3 over here of like 20, then I could say log base 3 of 4x equals log base 3 of 20. And if the logs are the same on both sides, you can say that that equals that. I don't want to say that you cancel the logs, but I will say that that has to equal that. And therefore x equals 5. All right, you're all caught up to where you're supposed to be, and your homework is graphing, and I'm going to tell you a bunch to skip. Take out your worksheet. Remember, I need 3 points in the asymptote. I will admit that there's a couple that go so far off the graph that 2 points in the asymptote would be enough, as long as you know that there's a curve. You get that if you have only 2 points, you might be tempted to draw a straight line through them, but you'd have to know these look like that. So if you have only 2 points, make a curve through them. So that's why 3 points is way better. Because what if the third point was actually here? Could a graph be flipped so it's like that? Yeah, it could. That's why 3 points is what you want. But if the worksheet isn't big enough to hold 3 points, fine, just put 2 points. Just got to put a curve here. Okay, pull up that worksheet. Let me take a look at it. Thank you. We'll do number 1 so everybody can at least get started. We are going to simply do the evens. I think that's enough practice for today. Odds. We're going to do the odds. Sorry, we'll do the odds. Because I said to do number 1. That'd be kind of cruel to the kids that did that. Odds. 1, 3, 5, 7, 9. Yep, just the odds. I know, it's half the worksheet. You feeling guilty because you're not doing enough work?
No, I'm saying that there's 11, 13, and 15.
So we're going to do all of the odds. All right. So number 1. Keenan, would you read it to me?
Y equals log base 3x. Or 3
Of x.
of x.
All right, good. And now what really matters here is your XY chart. I trust you know how to graph dots. That'll be the easy part. Jack, give me 2 good numbers to put in. 0 gives you the asymptote. 1, why is 1 good? Because it gives you 0, good. Who's got one more number to stick in? Shout it out if you know it. 3 would be smart. 3 would be better. Okay, so we'll stick in 3 in my head. I got log base 3 of 3, and that's 1. And then one more point. 9 works good. When you put a 9 here, it's really like 3 squared, so the answer is 2. From here, 0 is the asymptote. 1, 0 is a dot. 3, 1 is a dot. 9, 2 is a dot. And I know to draw the curve through this. And remember, you approach the asymptote. So this should get closer and closer to the asymptote, but not touch it. They do have arrows on each end. Because they go forever, but they can't cross that asymptote. All right, just doing the odds today. That's all I got for you for today.